Assalamu alaikum warahmatullahi wabarakatuh everybody, welcome to another video, and the topic today is minimum spanning tree. We'll cover two algorithms over here, Prim's algorithm and Krushkal's algorithm. So first, some minimum spanning tree. If you have a tree like this one, if you have a tree like this one, and then we'll have to find out the minimum spanning tree. That's more like a shortest distance among the paths, but not necessarily the shortest path. I don't know why this is jumping back to 2 again and again. I have no idea. I hope that doesn't happen again. Anyways, so Prim's algorithm gives the idea that you'll have to go through the algorithm maintaining two rules. Number one, make sure that you're maintaining a tree, and number two, make sure that you don't form any cycles. So that's okay. We have our conditions. Now let's go with it. So the shortest path we find over here is A and F, the shortest edge, the vertices. So AF, cool, it's 10. Then the thing we find is 28 and 27. 27 is the smallest one, so I will pick 27. And we have FE, which is 27. Then we have 28, 26, 24. Obviously this will be the choice. ED, Hebrew handwriting guys, 24. And then you have 28, 26, 20, 14. We will choose 14. Keep track of the vertices. We have a set. We have already visited A, F, E, D, and now C as well. Then we'll pick this one among all. We still didn't reach here because we have 28, 26, 20, 18, and 18 is the smallest one, and we have visited B. And last but not the least, G. And now since we have 7 vertices already, the algorithm stops, it doesn't continue. So that's how we get it. ED, and then DC, CB, and BG. And total, if you add them all, you get 10, 27, 24, 14, 18, 16, 109. That should be the answer. Let's see if it is. Yeah, there we go. That's the answer. So the key is to choose the smallest edge and maintain a tree as we go through the vertices. So it's very easy, and don't forget to maintain the set of the visited vertices. Once you reach the number of vertices, you have to stop the algorithm right there. So it's pretty easy, huh? Now we're going to go to another one which is even more easier, but that requires a prerequisite, and the prerequisite is that you have to sort it. So I'll show you a demonstration with my Hebrew handwriting. So you have 10, and then you have 14, 16, 18. I'm sorting it, okay? You have to sort it first. 20. Who's next? 24, 26, 27, 28, 24, 26, 27. My God. 28. So we start from the least. 10. Is 10 okay? Yeah, sure, why not? 10 is fine. Then 14. 14 right over here, DC, fine, no cycles, no problem. Good to go. 16 over here, no cycles, I'm cool. 18, still no cycles, cool. 20, uh-oh. If I take this, then this will become a strongly connected component cycle, and I cannot take this, so this one's a no. 24, yeah, sure. 26, oh no, if I do that, it will become a cycle again, so no. 27, sure. Now the algorithm stops because we have visited 7 edges and it's done. 1, 2, 3, 4, 5, 6. So sorry, it's not 7, 6, n minus 1 edges. So we are done. and that's how the algorithm stops. And even if you didn't stop, this will form a cycle if you take 28, so it's a no anyway. So that's Krushkal's algorithm, and you can remember that this is the same result as Prim. The only difference is Krushkal doesn't care about forming a tree. His algorithm somehow ends up becoming a tree anyway, and also gives you the same result of 109. And his algorithm also maintains the rule that you cannot have cycles. So we're good to go. Here is the result. I'm sorry for the horrible handwriting, but that's all I have, and that's Krushkal's algorithm. And with that, I end this video as quickly as possible, and until the next video, see ya and happy surviving.